Hey guys, so my name is Niladri aka Shumi, and in this series, me along with you are going to learn about generative AI. So, what are the prerequisites? Just a laptop and a good attention span and a little bit of Python. But don't worry, if you don't know it, I will try to explain while writing the code. Okay, so today is day number 1 and we'll be talking about LLMs. So in this video, we'll be talking about what is the LLM, how they actually work, what is the core mechanism of it, how we train a LLM, how it learns, what are the real world examples of an LLM, and what are the limitations of a LLM. Right? So let's get started. What is a LLM? You may have used an LLM before, like Claude, ChatGPT, DeepSeek, Gemini, Grok, for writing codes or basic generating text, right? So LLM is nothing but a large language model. It is an essentially a massive what pattern recognition machine that is trained on billions of text examples. So we may actually say it right. Uh, it is a most advanced and sophisticated autocomplete. Like they don't actually think; they predict the next word that is going to happen. Right. So for example, if we go into ChatGPT and write what is the capital of India, right? So it gives me that the capital of India is New Delhi. Each and every time it's giving me the correct answer, not each and every time, but how it's giving me the correct answer, right? So the thing is, it actually doesn't know that answer is New Delhi. It calculates that based on pattern it's seen millions of times, the word New Delhi has the highest probability of the coming next. Means when it sees that the word capital and India comes together, the chances of getting the word New Delhi has the highest number of probability. So it predicts the next word, right? So if you ask ChatGPT to write you an essay of 300 words, so what it does, it generates word by word and it predicts the next word. Now, what is the word large in large language model means, right? It means the number of parameters. How many number of parameters that the model has. What is a parameter? So it is an internal value that stores the model's knowledge. So there are various types of parameters that helps LLM to generate. So we are not deep diving into machine learning. So a brief description would might help. So now the second part. If we head on to Google and we search what is a LLM. So what it does it. So this section was not before. Google has introduced it while integrating Gemini, but before that it was indexing me the links. It was not generating an answer for me. But now the Gemini is generating me an answer. So how it's working? Let's deep dive into it. Okay, now let us understand what is the core mechanics. So when a user goes to ChatGPT, right, or any LLM, and gives an answer, or any LLM, and suppose asks hi, and it generates you, hey, how are you, right? So this here is the input token, and this here is the output token. Okay, what is tokenization? Before that, let me make you understand about what is even the word GPT means. So the word GPT stands for generative pre-trained transformer. Okay, so the nature of an LLM is generative in nature, means it generates an output, and it is pre-trained. Suppose means I am making this video, so I am pre-trained on this topic. I know what to say and what not to say, right? And a transformer is basically a reality, means the models. So, ChatGPT, GPT, or Gemini, or Mistral, any of these models are called transformers, right? And they are pre-trained, okay, on what? On giving you a generative answer, right? So GPT. Now let me show you three-step process that happens every time you hit send, right? Step number one is tokenization. So what is tokenization? So your text gets broken into tokens, not words, not words, right? Suppose a word understanding might become under and standing. So why you do that? Because it's more efficient. The model works with around 50,000, 1 lakh possible tokens each time, right? The second step is embedding. So what is embedding? Each token becomes a vector. So a list of numbers that represent its meaning in a multi-dimensional space. In multi-dimensional space. So previously I was giving you an example, right? When our word India comes with a word capital, the chances of getting or the probability of getting the word New Delhi is more. So here's the magic. Words with similar meaning end up close together in the space, right? So the step number 3 is transformer architecture. So this is where the neural network magic happens. Means the model uses something called self-attention, right? To figure out which word in your prompt matters most for predicting the next word. So it skips all the bullshit contents and just focus on the right important word. So if I give you an example, suppose a sentence, ki, the trophy doesn't fit in the suitcase because it's too big. So here it refers to trophy. So the main important thing here for the LLM to focus is trophy, the word trophy. And the attention mechanism figures this out by looking at relationship between all words simultaneously. Now we are going into the third part of how it learns, right? How it learns. So there are two phases of learning. Phase number 1 is pre-training. So the model reads a massive chunk of the internet, books, Wikipedia, website, codes, or even your sit post, right? It predicts the next word billions of times to give you a sentence. So it's not generates a sentence at a time, right? It's each and every time it's predict just the next word, and it does it every single time to generate your sentence. Imagine showing someone the sentence, the cat sat on the what? You may guess mat, right? So let me give you a real world example. Suppose you have fed it, means you have fed an LLM a Python code millions of times. So it genuinely learns that after defining function name, we put the parameters or we put a semicolon right there. So it knows the thing now. And phase number 2 is fine tuning. What is fine tuning? After pre-training, the model is very chaotic, right? It might be overfitted. So overfit or underfeed, the two terms are goes to machine learning. So in brief, if I may simplify it to you, that overfit means feeding a model excessive amounts of data So when asking an answer, it may take some random Reddit arguments or bullshit takes from the internet, right? So we cannot do that. We need to fine train the LLM, right? And this can be done using reinforcement learning from human feedbacks and etc. These are some machine learning topics. I am not covering this because we are learning about generative AI. Now the next part we'll talk about limitations of an LLM, right? So three critical things to understand. Number one, no true understanding. So no true understanding. So what it does, it's basically matching the pattern. It's not comprehending the answer for you, right? So I'm giving you an Easter egg. Try it on LLM. Ask it how many R's are there, okay, in the word strawberry. So it might fail because it never learned to count letters. It learned to predict the next pattern. Okay. Number two, hallucinations. So if the patterns are ambiguous, it's generally hallucinates. You have heard Gemini, that the Gemini while providing codes hallucinate, or the Claude models are hallucinating after giving you a certain number of lines of code. So the thing is, if patterns are ambiguous, it confidently predicts plausible sounding nonsense response. It might cite fake research paper that sounds right. Or the most important, and the third is training data cutoff. So what is this? Most models don't know anything uh, after their training date, or they are frozen in time unless they have some web access. So date cutoff. Now to sum this up, so that's LLM. Massive pattern predictors that turn into numbers, use attention to understand context and predict one token at a time. Always remember, one token at a time. Okay, not magic, just really good mathematics. So that's it, and in the next video we'll be talking about implementing a custom tokenizer in Python. So this was an interactive video, and to give a quick recap about LLMs and everything. So see you tomorrow. Thank you.